quality brew, that. Oh, it's you. My name's Carl Wilson. Welcome to my channel and welcome to my workshop. In this episode, we're going to be looking at how I took the knee and lead screw off my Harrison horizontal vertical milling machine and the trials and tribulations that I went through to do that. And I'm now going to be showing you a short piece of film that I took when I went down to visit Mr. Matthew Luck. I stayed in the cottage that he's renovated with my daughter when we were down there visiting, and we had a fantastic time. And Matthew showed us his workshop and the shed where he's rebuilding the Land Rover engine for his Clanger project. And Matt's excellent. His channel is called Luck Creations, and it's just a first-class place to go if you're interested in machine rebuilding and engineering, lathe work, milling, that type of thing. The type of stuff that you're watching my channel for, really, apart from the excellent machine rebuilding skills. Now, Matt is really, really good at scraping, and I would say, personally, he's the UK expert on scraping, certainly on YouTube anyway. So it's definitely worth getting yourself over there and watching his videos and finding out what he's getting up to, because he really is first rate. So without further ado, we'll crack on now and we'll start getting the knee off this milling machine.
Hello.
My name's Carl Wilson, and I'm not in my own workshop at home as I usually am. I'm today with Mr. Matthew Luck in his workshop, restoring or rebuilding rather his Land Rover engine. And I would advise you, if you're watching my channel, to be watching this man, because when it comes to engineering and machine rebuilding in particular, he is the maestro. And I would, in my opinion, he is the master of scraping in the United Kingdom, as far as I'm concerned. So get yourself over to this man's channel and check it out, because it's excellent and I've learnt so much from him. So you get yourself over there, and you'll learn from him as well.
Thanks for the compliments, Carl. I'm nowhere near the UK expert. There's plenty of guys better, but
I've yet to meet them.
Yeah, well, that's it. Perhaps I'm the best you've met, perhaps.
No, I've yet to see them anyway, but I've learnt so much from you, so thank you very much. And
It's been a pleasure. Thanks for coming down.
And we've also been staying in Matt's cottage, which he's renovated himself with his son and daughter. The daughter who is currently holding the camera filming this, so thank you very much for that, Emily. And so get yourself over to his channel for that as well, because that's really worth watching, how he's put the village back together and basically rebuilt it from an empty shell into what is now a fantastic holiday let. So yeah, it's really good. Get yourself over there.
And the discount if you're going to come and help me with the Land Rover.
Absolutely, yeah. So we'll see you all soon. Thank you very much. So this is the input side of the knee lead screw operating mechanism. And what we've got here is a cast iron sleeve which enters through the knee casting through this opening here. And it's held in place into the knee casting by these quarter UNC SHCS, and it has a locating feature which on the drawing looks like a dowel, but in actual fact is a roll pin. And there's two of these roll pins, or grooved pins as the drawing refers to them. And then in this sleeve we have journaled at the front and rear by these two bushes the steel shaft which runs through the sleeve, and then on the steel shaft we have this helical pinion which engages a helical gear on the lead screw, and that's butted up against this shoulder on the shaft and then secured in place by this what's called a Simmons lock nut in the drawing, but is actually in modern parlance a nylock nut. And because we have a helical pinion, we're going to have some axial thrust. So we have these two thrust bearings, and these are SKF open construction thrust bearings. And at this end we have the micrometer dial, and what's shown here, not very well it has to be said, is the arrangement for setting up the friction for the micrometer dial so it stays where it's put. And basically you have this brass die which is pressing up against the steel shaft, and that's compressed against there by a compression spring which is preloaded by a 5/16 UNC grub screw, which is also not shown. And this arrangement on my mill, I have two of them, and they are 120 degrees spaced around the periphery of the micrometer dial. And up here in the the knee casting, we've got this lubrication nipple, which feeds down through this hole into the bushes and lubricates the whole assembly. Although it's difficult to see how it's going to get to this particular bush here, so maybe we'll have to do something about that. We'll see. Anyway, these things are the bane of my life because they look exactly like grease nipples, and as you can imagine, someone has been assiduously greasing them for decades. So everything on this machine is absolutely clogged up with grease, which is an absolute joy to remove, as you can imagine. So now we've looked at the basics of this assembly, we'll now have a look at what this drives, which is the lead screw. So we're now looking down inside the knee casting. Look at all that horribleness in there. I would hate to have to be the person that has to deal with all that. Yeah, right. So what we've got there, trying not to obscure the light, you can see there the helical pinion that I was talking about just now on the drawing. And there's the Simmons nut on the end of the shaft. And you can just about see, just there, one of the SKF thrust bearings. So believe it or not, underneath all that crud and whatever it is, there's a nut. And that there is a helical gear, bizarrely enough. So it seems to me that the plain portion of the lead screw is actually running in, it must run in a couple of bushes in much the same way that the shaft for the pinion does in the sleeve, which you can see a little bit of just there where I'm pointing now. I'll show you a little bit more of what I mean by this, but I've just had my fibre optic ender probe down in here, and you can see there's kind of a tower, for want of a better word, in the casting, which this must run through, or does run through, and that must have bushes inside it to support the plain section of the lead screw, as I've said. So I'll move the camera now underneath this location to look in kind of this way, and you'll see what I'm talking about with regards to this, what I suspect is this bush arrangement. So here we go. Here is the offending item, the lead nut housing, and I have briefly touched on this damage on here in part one. What you've got there is the remains of what I suspect was probably a 5/16 UNC tapped hole, and then this crack's propagated from the threads, they've been the stress razor, and at some point this whole section here is broken out. Now you can just about see on the lead nut there's like a keyway, a slot milled in it, and I suspect that slot was actually at some point lined up with this hole, and there's been a dog point grub screw in there engaged in that slot as an anti-rotation feature to stop this nut from spinning in the housing when the lead screw turns. So the other thing you can see about this as well, and you can just about make it out on the picture, on the image I've got here, is that this is actually raised as well. It's tried to jack itself out at some point. So none of this has been having a great time by the looks of things. But whilst I was looking at this and having a bit of a deep dive into it, I found something else as well, which I'm going to show you in a minute when I move the camera around, which is someone's tried to do something about this, the fact that the anti-rotation features come adrift, and the nut has actually spun in the housing, and you're going to love it. So I'll show you it now. I'll just get the camera repositioned. So that's a 1.5mm drill shank. It's quite happily going in that gap. So this nut has lifted. So it looks like whatever that anti-rotation feature was also holding the nut in place in the housing as well. But check out this little doozy here. It's quite interesting. I'm going to take that out and I'm going to show you what it is, and I'm going to tell you what I think has happened there. So I found this funny little grub screw here, and it wasn't mentioned on any drawing, and because it's silver in colour, or kind of natural metal colour, it blended in with this horrible paint job. So I came and I took this lubrication nipple out, and I saw it, and I thought to myself, what's that all about? So I went to go and take it out, and everything on this machine is either UNC or UNF, and my socketed Allen key wouldn't go in it, the one I thought it was, and lo and behold, it turns out to be a 3mm. So I take it out. I'll do that now. I took it out, and it's none other than a just get my hand in there, take that out and show you. Lovely shot of the hand there. It is none other than an M6 dog point grub screw. So it looks to me, cut a long story short, as though what's happened is this this crack's occurred here, and obviously the dog point grub screw that was in there, that was in the anti-rotation feature in the nut, that also secures the nut in position, I believe. When that's gone, somebody's decided to repair this or bodge it. We'll use the term repair. We'll be generous. They've drilled a hole in the nut housing. They've tapped it M6, and they've just horsed an M6 dog point grub screw in there, which has probably kind of buried itself in the nut, and that's been their repair. So I'm expecting to find that to be somewhat gouged when I take this nut out. I mean, it might not be too bad, because maybe this lifted and then they put the grub screw in. But I'm just looking around the back of there, and it looks like the gap's uniform all the way around, so it might not be too bad. But anyway, we'll crack on, and we'll get this this lead screw out now, once we've cleaned all that muck out. Oh, can't wait for that. And there she is, yep, little M6 grub screw. So I've been trying to come up with a convincing hypothesis about how this damage and the lift of the nut happened. And the two scenarios I've come up with are either the knee was fully bottomed out in the position that it's in now, and somebody cranked on the mechanism and tried to operate the lead screw, and it's jacked out the nut, because obviously the knee can't go any further down. Or they've had the locks engaged and they've cranked on the lead screw, and that's jacked the nut out. I think I prefer the former idea above the latter. When this is fully bottomed out, it makes more sense that they've done it then and it's jacked the nut out. That casting of the nut housing is, as we've said before, grey cast iron, so it's not going to take too much of that kind of punishment. A tensile loading like that and a shear loading on this, presumably what was a grub screw, that would just pull that out in no time at all. Or at the very least it would produce a crack, which would then over time have ended up like this. So that's what I think has happened. That's how come I think that's jacked itself out of there. And someone came along and put that natty little M6 grub screw in there to effect a repair. Well, you know, we're being generous by calling it a repair, as I mentioned earlier. So we'll see what kind of damage that's done to the lead nut when we get it out. It's a little bit like archaeology, this, isn't it? I feel like I need a trowel or something. But I think I'm going to have to get my hand in there, you know. I think it's going to be the only way. Right. I know I've been kind of loath to remove this knee from the actual the main body of the machine from the vertical ways, but I think I'm going to have to do it at some point just to get all this dirt from the inside of here. Look how horrible that. Ooh, that's horrible. Look at it. 50 years worth of grease, swarf and other detritus. on the bright side, we can almost see some sort of fastener starting to reveal itself to us in there. We'll keep on and see how we get on. I think it was John of John's Workshop who said to me that I needed to get blue roll or paper towel on repeat order for cleaning this thing out. So John, I went to my local cash and carry place today, wholesalers, and I did just that. So let's carry on, see if we can't unearth some more. Well, I can almost see a nut now, and I can actually see some gear teeth, but I think it's no good. I'm going to have to get my hand in there. There's no getting away from it. So, gloved up, in we go. Oh dear me. Now this has some kind of shades of James Herriot about it, this, which will mean absolutely nothing to you if you're not from the UK, that reference, but I'm sure you'll get it if you are. Right, I can see the nut. Interesting, that gear looks like it might be phenolic. I could be wrong, well, perhaps not, but we'll see when we get it off. It's probably just a trick of the light. No, I don't think it is. Right, I can actually get something onto that nut now. So I'm going to try and remove that and see where we go from there. Bring you back in a second. So you've got a fairly decent view down the hole, so to speak, and I've tried to get the light in there so you can see what's going on. You can just about see the helical gear there and the nut on the end of it. So that's 3/4 AF. I'm going to take that nut off now and then see where we go from there. Get the hand in. Right, there we go, one Simmons nut, and we'll take the washer off, if I can get the washer off. Just about get my entire hand in there. Now it really does look like something off James Herriot. Yeah, oh, come on, it's like working on aeroplanes again, this. Nope, I'm going to have to get some assistance. I'll bring you back. So, there we go. There's the washer off. Now, I don't know if I'm going to be able to get that gear off, or if what else I'm going to be able to do. So, I'll bring you back in a minute when I've decided what I'm going to do. So, the gear is nice and loose on the spline. What's locking it in place, you can't see very well, but I can feel. What's locking it in place now is just the mesh with the helical pinion. So I think if I rotate that helical pinion now, the axial thrust of the action between the pinion and the gear will actually drive that off the shaft for me. So I'm going to do that. So that's the handle onto the input side, the pinion side. It's not actually the correct one. That's the handle for the carriage, or the saddle rather. But it's the same spline, so I'm just going to use it because it was close at hand. And if that looks familiar to you, if you're a Harrison lathe owner, it's because these mills, the Harrison mills, mechanically they're identical to, or they use many of the same components as the Harrison L5 lathe. So I suspect that's probably a Harrison L5, or even possibly 140 tailstock operating hand wheel. So it might look familiar to you. Anyway, we'll try and get this gear off now. So here we are, we're back with my best bit of POV filming, and you're not that innocent, I know you know what that means. So turning the handle now that you've just seen me put onto the input shaft, and you can see the end thrust is actually lifting the gear already, so it looks good for this coming off, I think. So I'll give it a shot, get my hand in there again, James Herriot job. Yep, there we go. It's worked a treat. Now I've just got to get it out, and that'll be the thrust washer. Don't want to lose that, or thrust bearing I should say. It's gone kind of sideways in there. Right, this is a lot like working back on aircraft. Okay, I am not going to drop this on camera, even if I have to cut my finger off. Here it comes. Right, there we go. There she is. So we'll have another look at this a bit closer in a minute on the bench with better lighting and a better view, basically. Right, I'll try and get this bearing out now. So there's the bearing, the thrust bearing, and you can see the pinion there as well. So I'll get my hand in there again now, and I'll slip that thrust bearing assembly off the end of the shaft. So here we are. This is the upper race of the thrust bearing, and here's the rollers in the cage. The bottom race is still actually in position. See if I can get this to focus, if you can see it properly. There you. I'm not sure if that's going to come off. I think it will do. It seems to be just sat on top of the tunnel as I described it before, where the bearing bushes are for the lead screw. So I suspect that'll come off when I take the lead screw out. So we'll move to do that next, I think. So there's what I think is a better view of the lower thrust race, and you can see the splines as well on the lead screw shaft that the gear was engaged with, and the threads where the nut was. And when I put my hand in there to get that bearing out, there was a horrible piece of sharp swarf just in exactly the right position to stick right into my thumb. So just so you know, I am suffering for my art when I'm doing this. So I think what I'll do now is I'll try and extract this lead screw, and I'll show you how I'm going to do that, and then we'll get on with it. So we're now looking up inside the base weldment, which you can probably tell from the strange echoey sound of my voice. So there's the lead screw. That's where it runs down through into the base and terminates there. So what I want to do now is by hand rotate the lead screw there, and it should screw itself out of the knee. Okay, so what I'm going to do is put the camera in this position here at the base of the knee, so you can see where the lead screw actually protrudes, and I'm going to rotate it and see what happens. No, I'm not, because it won't move. So I somewhat naively assumed that I'd be able to rotate this lead screw from underneath where I showed you inside the base weldment, but it doesn't want to budge at all, which is now leading me to suspect that the plain portion of the lead screw shaft inside the bushes up in the knee here might be seized. I've heard of that happening before with these machines, where the inside of the knee is subjected to flood coolant and the vagaries of dirt and whatever else that gets in there, and it seizes up the bushes or the plain portion of the lead screw. So what I'm going to do now is put the gear back onto the lead screw on the spline and rotate it using the hand wheel. I mean, when I first got the machine, I did try to rotate it and it did turn. Obviously the state of the way is being covered in grease. I didn't want to move it up and down too much, but I know it did turn, so we'll try and see if we can get any movement out of it now and see where we go from there. So that's me, got the gear back on and the nut. Everything's engaged, and it's really tight. I mean, I know it's not the right handle, it's a smaller handle and less leverage and whatnot, but that is tight. So I can see the knee driving up and down, but I would have expected it to have been I mean, it's taken me both hands to do it. I would have expected it to be a lot less onerous than that. So what I'm going to do is take that gear off again, take the nut off and the thrust washer, thrust bearing rather, and I'm going to get some penetrating oil in there. I've got some stuff with colloidal graphite in it, so I'll get some of that down in there and leave that overnight, and in the morning I'll try and see if I can rotate this again, because I would have expected, when there's no drive on that, there's no gear in mesh and everything else, I would have expected to be able to turn that. I mean, I could be wrong on that score, but I would have expected that that would have turned with some effort, but I would have thought that would have gone by hand. So anyway, we'll get some penetrating oil on it and we'll see what that does. I always use these plastic trays, by the way. They're old Chinese takeaway or Indian takeaway food trays. I use these to keep parts in, so that's what I had the gear and the washer and the nut and the bearing in. So I always do that sort of thing. I like to try and keep things organised when I take things apart and hopefully reassemble them. So we'll get some penetrating oil on that now, and then we'll see what it's like in the morning. So I'll extract this washer again. I just put the camera back on because I wanted to show you this gear. Once I get it out, I'll put the hand wheel on there so that I can just kind of use the end thrust to get it off. Okay, that's it off. I'm just going to get it out now. Don't drop it, Carl, whatever you do. Okay, so there we go. I thought it was phenolic, but it's not. It's steel, I think. And you can see it's got a spline bush for the drive pressed into it. And that side's obviously where the thrust bearing's been. So as I said, I'll get some penetrating oil in there now, and we'll see what it's like in the morning. So this is what I'm using, Ease-It. I used to use it on aircraft, and it's good stuff. It's basically it's kind of a light mineral oil with almost like a WD-40 type of stuff with colloidal graphite in it. So I'll just apply that with a suitable small brush. We'll get some in there. Brings back a lot of memories, the smell of this stuff. It's funny how smell can evoke memories, isn't it? Apparently the olfactory senses are one of the strongest kind of things for triggering memories. I believe it, because that takes me right back. Right, let's let that get in there. Hopefully it will. And we'll see what that's like in the morning, as I now must have said about 10 times. So there we go. Let that do its thing. Right. See you in the morning. So it's the next day now, not just the next morning, but the next evening, in fact. And so the Ease-It's had a good chance to work. It's been in there about 18 hours now. So I've put the nut back on to the plain portion of the lead screw, the nut that was securing the skew gear on, or the helical gear rather, and I can get some movement on it now. It does turn, but I'm not overly fond of the idea of screwing this lead screw out through the nut. I still can't really turn it enough to get it out, turn it by hand underneath, as I showed you before. So I've had a change of tack. So I'm going to explain that in a minute, what I intend to do. And I'm just going to show you again underneath the knee, so you can see the thrust bearing that's underneath there that is on the plain portion of the lead screw. So we're underneath the knee again, looking at the just above where the lead nut is, and you can see here this is the lower thrust bearing, which is inside this brass cover, and you can just about see the upper race there, and that just slips up and down. I think I can show you that if I get my other hand in. It's a glove job again. There you go. So that just rests against the top of the thread there. There's like a machine portion for a register where that sits, and then that bears against underneath the that pocket there, underneath the knee. So what you can see there is I've got about 30mm, just over an inch of the plain portion protruding now from the bushes inside here where these are journaled, or where this is journaled rather. And I've managed to achieve that by, as I said, soaking it in Ease It overnight, and then I put the nut back on to the threaded portion above here and locked it to another nut, and I was then able to rotate the lead screw with a ratchet handle and a socket, 11/16 socket on the nut, to get it to this position. Now the idea was that I would screw this lead screw all the way through the nut and out through the bottom where I showed you earlier on in the base weldment. But in order to do that, it means trying to turn this by hand by some means, actually holding the screw itself, because obviously once I get the nut on the threaded portion down to the base of where the bushes are in the sleeve inside here, or the tunnel as I've referred to it before, then I have to take that nut off for it to pass through. So then I have to somehow grip this to rotate it, and I can't really do that. I've tried various different methods. I've put some protection around this, I've had a strap wrench on it, and I can't effectively turn it. So what I want to do is something that I didn't, or I was hoping to avoid, which is to remove the whole knee casting from the vertical column of the machine. Now there's a gentleman on the MIG welding forum that I very often used to frequent, and I had a thread running on there about the refurbishment of this machine. And a gentleman on there by the name of Hugh, who's also got one of these machines, but he's got the universal version. He advised me not to remove the knee because he had a lot of issues with setting it back up again, the clearances for the ways, because I think I mentioned in part 1 of this series that there's actually no gib inside the keeper plates, between the keeper plates and the rear of the ways. So Hugh informed me that it was very difficult to set it up again. So there are some shims, I believe, inside there that set up the clearances. So that's the reason why I didn't want to take the knee off, but now I think I'm going to take it off, because it's going to be easier to basically lift the whole knee up and take the lead screw out by undoing the bolts that secure the lead nut housing on, and I can show you them now so you can see them there. There's another one round the back, just get that to focus hopefully. Yeah, not too bad. So there you go, you've got these 1/4 UNC bolts holding it in. So if I take those out, then the whole assembly, the lead screw, the lead nut and the housing should lift up vertically out of the base weldment, and then that'll give me easy access to get in to remove the sleeve and the mechanism for the input side, and also it'll give me a much better access to the bushes that this thing's journaled in, the plain portion of the lead screw. There's obviously something going on with them, because that assembly was really stiff in there. I mean, it doesn't look that bad. It looks nice and clean, the plain portion, but we're going to have to look at those bushes, I think. And also the inside of it needs a really good clean. The other thing that was a little bit concerning was that when I was rotating the lead screw with the socket and the ratchet, as I described earlier on, it would go, it was loose for maybe 1/4 of a revolution, then it would go tight, then it would go loose, then it would go tight. So that kind of implies that it could be bent, the lead screw could be bent. I really hope that it isn't, but in order to check that, we're going to have to get it all out. So what I'm going to do now is get set up for lifting this knee off, which means disconnecting the keeper plates and putting some rigging in place to get the engine crane in to try and get a nice straight lift and get it off here, and then we can get it examined. So I'll bring you back when we're ready to do that. So as I've said, I'm going to take the knee off to assist us with dismantling everything inside it, the lead screw mechanism. So it's held on as I think I mentioned this before in part 1, that you've got this this block here, clamp block, which in the manual is referred to as a strip, and it's held on by these 4 5/16 UNC bolts. So that basically clamps the knee assembly to the ways. So you've got the V-way here, and then that sits on the back of the V-way and clamps it all together. You've also got the what they call the locking stud here, which gives you the lock. Basically, there's just it's a wasted bolt basically with a groove machined in it, which clamps onto the back of the ways when you tighten this up, and a couple of lubrication nipples as well. So I'm going to do some preliminary work now before I start taking this off, and the first thing I'm going to do, these are handed, so I'm going to center pop them, just a light center pop, just so that I don't get them the wrong way around when I put it back together. So I'll do that on the other side as well. So I'm going to take these lubrication nipples out now with a 5/16 AF socket. So I'll get them out, because what I don't want is any possibility that they might get snagged or bump into something when I'm moving it around on the crane and get broken off. So you can imagine when that's going to be full of. Yep, like everything else is on this thing. So the next thing to do, I think, is I'm going to take the wiper plate off the way wiper. So I'm not sure what size bolts they are in there, but it's I think it's a 5/64 Allen key, I think. So I'll do that now. Get these out. I've actually made sure there's no gunge or anything in these tiny little countersunk socket head screws. So I don't want one of them rounding out and having to drill it. So I'll just tip you up a little bit so you can see what I'm doing. There we go, and around a little bit as well. There you are. So that's the wiper plate and the wiper underneath it, and it's sandwiched by another wiper plate below. So we'll get this off, and then we'll talk about rigging for getting the knee off, because I want to have this on the crane ready to go before I start taking those 5/16 socket headed cap screws out that hold this on. Fortunately, none of these little things is being obstinate, which is a good thing. I'll find out what size these are and I'll let you know. But suffice it to say, they're toty wee things, as they say around here. So we'll get this, probably got a really good view of my lug. No, it's not so bad. Not as bad as I thought. Right, let's get this out. Yep. My camera positioning skills can only improve, I think. They can't get any worse, can they? Let's face it. Right, let's get this out. Right, now this should now lift out. It's been a pain. Long nose pliers to the rescue. Or I could have just gone round there, I suppose, couldn't I? But you know. Right. Let's get this plate off here. Everything's covered in swarf, as per usual, and grease and all kinds of other gunge. There's the wiper coming off now. There we are. And it's not in too bad nick, actually. But, I'm sure we can afford to have a new one. Let's get that off. Right, so that's the... It's just everything is just manky. Look, encrusted. Right. Enough complaining. So that's the wear wiper off. I'll now get some rigging on this I'll show you what the arrangement's going to be, and then we'll get these 5/16 out and we'll get this thing off. Right, so I'm going to show you now the rigging arrangement, which is rather a grand word for what it is, that I'm going to use to lift off this knee. So it's all going to be composed of basically parts from a clamping kit. So this is a M10 clamping kit. So that's obviously a clamp bar, double nutted to a clamping stud. So that can't move, that's locked on there. That then can go through the gap in the top of the knee, and I can turn that round, and then that's got a good firm placement inside there, inside the knee, towards the rear, which is where I, just roughly looking at it, where I believe the CG is. And that straddles in there quite nicely. It's a good inch either side, and this is about 40 mil, so about 1.75 inches thick, so it's meaty. It's not going to come out. So once that's in there, if I can just hold it with my other hand, I'll try and show you. I can get another clamp bar on the top of this with a couple of bits of hardboard just to protect the ways. Put another nut on that, or even put the pad eye on there and put a nut on, and then I'll have the pad eye screwed on tightly, holding the whole thing together, and then put a shackle through the pad eye, and we can lift this off. And now, I don't think Lloyd's of London are going to certify this, but it's going to be more than strong enough to do the job, and it's going to get this knee off safely. You know, avoiding any kind of home workshop sketchy lift scenarios. Now, you could probably say that the pad eye that goes on here should maybe have a swivel on it, and I would agree with you, but I don't have one that can do that. So I'm just going to have to be careful to make sure that the nut doesn't unscrew. To be honest with you, I don't think it will. I think it'll be alright. Now, I've worked out that this is about 1 metre off the deck, and I need about another ½ metre to get the lead screw out. So I've checked on the crane, and I should have enough headroom on the crane to make the lift to get the lead screw out. So I'm going to look very silly if I've got that wrong. But there's only one way to find out, so we'll get this arrangement set up and we'll get the crane on and we'll have a go. So we're just about ready to make a lift now. This is a general arrangement view of the crane and where it's sitting in relation to everything else. I'll bring you in a second and show you the close-up rigging arrangement and everything else. I had to take 2 of the jacking casters off the lifting beams so I could get the crane in, because I anticipate having to do slight adjustments to the crane's position so I get a straight lift as that boom's coming up. So I wanted it to be in there without fouling anything. And incidentally, the jacking feet on the other end are both up, and the machine's firmly on the ground, in position for the lift. Those lifting beams, I made them so I could get the machine off a pallet, and they're really handy for moving it around in the shop, and they've made everything a lot easier. And I made a video about how I put those together, so it's worth a watch, I think, if you're wondering what they're all about. So I'll take you in now anyway, and I'll show you a close-up of everything that we've got here. So here's a close-up of how everything's rigged. As I said before, I've got the you can see just inside there, you can see the toe clamp from the clamp set, and it's lock nutted to a clamp stud, and then that toe clamp is firmly engaged in there across the bottom part of the knee casting. So that's not going to go anywhere, and then it's clamped on top by another toe clamp which has the pad eye bolted on top of it to keep it in position. And then I've got these bits of hardboard just to protect the ways, and I've also added some extra protection. I just gave them a quick degrease with some methylated spirits, and then I threw some of this frog tape on. I know it's not going to stand up to a blow from a sledgehammer or something like that, but it's just a bit of protection for them for when I'm moving the knee around and working on the internals and the mechanism, just so they don't get any nicks or scratches or dents. So this is going to do the job for me, I think. This is a 3/4 ton pad eye, and it's a 2-ton shackle. So and the crane can lift about 1/4 of a ton in the position that it's in now. So we're going to be fine. As I said before, it's not going to be Lloyd's of London certified, but it's certainly going to do the job. So preliminary work that we've done, you've seen before, I centre popped these, the strip, the clamping strip rather, and the knee itself. I've removed the handle from the locking bolts. I've taken out the grease. That's me talking about that now. I'm getting as bad as the previous owner. Taking out the lubrication nipples. So the only thing that's holding it on now is the 5/16 UNC bolts on both sides, and also I have to remove the quarter UNC bolts that are holding the lead nut. What's the word for that now? I keep forgetting my words. Yeah, the nut housing is what I'm talking about. So they've got to come out. Those 5/16 have got to come out on both sides. I've taken off the hand wheel that I was using to operate the mechanism, just to get the gears displaced, to get them out, so that can't fall off. So we're in a good place for lifting this off. I'm not going to attempt a lift tonight because I'm too tired, and I want to have a clear head, a fresh pair of eyes, run around it one more time in the morning just to make sure everything's ready to go. And then what we'll do is, after I've removed all those bolts that I've just spoken about, we'll do a test lift. We'll see what the CUG is like. We'll see what it's behaving like, and then we'll go ahead and try to remove the knee and the lead screw complete. Hopefully we'll be able to lift it up relatively vertically, and we can get that lead screw out of the hole in the base weldment. So yep, the next time you see me, it'll be tomorrow. Okay, it's the next day now, and I'm having a slight change of tack in regards to removing this lead screw and nut assembly attached to the knee with the lift. I think what I'm going to do is I'm going to take the nut housing off here and try to wind the nut up the lead screw, and then pull the lead screw down through the journal here, and then wind the nut back up a little bit more, and just keep trying to get this to come out that way, because I'd really like to have this lead screw out before I do any lifting. Thinking about it last night, I don't really want to lift the knee with the lead screw and try and have to jiggle the crane around and maneuver it to get this lead screw out in a linear fashion, in a straight line. So I'd rather have this out first. So I'm going to clean this thread up here with some methylated spirits, get all the crud off it, so I can be sure that this is going to thread up it without any issues. And then I'm hoping that the nut itself will run up the screw in a relatively easy fashion. So we'll see. I'll get some easy in there as well. I'll get some. Just get this methylated spirits on there now and get it all cleaned up, or as clean as we can. Make sure there's no detritus on it that's going to get jammed up in the threads. I think I'll just get a stiff brush into there with some solvent on it, with some meths on it, methylated spirits, and I'll bring you back when I've done that. So here's more mediocrity for you. This is me having at it with the brush and the meths, the methylated spirits, or wood alcohol as some people, some countries call it. So that doesn't look too bad now, it's pretty clean. So I'll bring you back in a second, and we'll try and thread this up the screw once you've got these quarter UNC bolts out. So I've cleaned the thread now, and got some ease-it in here, which I sold you a bum steer the other day. It isn't colloidal graphite at all. It's actually white spirit. It's actually kerosene and barium sulfonate, which I believe is a corrosion inhibitor. So there you go. Now you know. Right. So we'll just get all the the gunge out of these hex heads with a pipe cleaner, or as much of it as we can, and make sure we get a good engagement with the socketed Allen key. You won't see me use conventional Allen keys very much. I much prefer the socketed variety. I find them to be much more versatile to get into places and use with different types of tooling. As my brother says at Retro Mechanica, Allen keys are for building flat pack furniture with. Right, so there we go. Let's round that side. You can't really see, so let's take these quarter UNC bolts out and have a go at rotating the nut along the screw and see if that takes us any further down the road to getting this lead screw assembly out. Incidentally, I've taken the Simmons nut off the top of here, so there's no impediment to this coming down the way now. So hopefully once I've moved this up a bit, it'll give me some room to take the plain portion out of where it's journaled in there. And I've been going on about there being bushes in there, but there might not be. That could well just be running through a board bit of the casting, so it's basically steel against the cast iron. Well, we'll see anyway. We won't know until we get it all out. There's my little box of bits. Let's reach round in there for now. There we go. Always like to have a plastic box handy for all the fasteners and other bits and pieces. That's the second bolt coming out now. It's fascinating, isn't it, this? I should be doing the commentary for the, I don't know, the Edinburgh Tattoo or something. Right, that's that one. Let's get the last one now. It's a hand in the way of the camera. That's fantastic. Right, now, as me talking about not using Allen keys, I might actually need to use one to get to this one, because it's a bit tricky. Right, can I get to it? I'm determined to get to it. I think there's still some gunge in that one. Come on, out you come. Let's get that in there. Yeah. Right. I think I shall have to do something different with that one, so I shall bring you back when I have decided. Okay, so that's got the last quarter UNC out. I actually thought there was something wrong with the head, with the socket. However, it was just swarf and grease that had actually gone in. It was so compacted in there, it almost gone hard. I just had to dig it out with just a small screwdriver. So yeah, unbelievable really. But the good news is I can now rotate the screw, rotate the nut rather, and the screw is coming downwards. So we're going to have the screw. So that actually turns quite freely now. I don't understand why I couldn't turn it before. That kind of smacks of some sort of misalignment, doesn't it, really? That we couldn't get that screw up before. So I'm now turning it from underneath. Right. Okay, so let's have a look and see what we've got here. That's going to slide up like that, and that should enable me to take the lead screw right out of the nut. Is it gonna? Yes, it is going to slide over the spline. Yeah, that's odd because that was absolutely solid before. But as soon as I undid these, quarter UNC securing bolts, it's come loose. Right, that's still in the nut. I just want to show you this thrust washer. So that was just sitting in that brass cup, if you like, which is supposed to stop it from getting all swarfed up, and by and large it has done. Right, we'll continue rotating the... There we go, it's out. Oh, am I going to be able to get that? There we go, so there's the nut, which we'll have a closer look at in a minute. It looks good, to me anyway, on the inside. Don't know if you can see that very well. Can I get you? Not much. The light's not very good, is it? We'll have a closer look at it in a minute on the bench. So there's the nut off, and oddly enough, it's absolutely manky with grease, just as I thought it would be, like everything else is. Can I get this? Yeah, I can get it out this way, so you'll get a good view of the lead screw as it comes out. It's quite interesting actually when you take this apart. I don't know if you can see. Yeah, you can. Inside here you can actually see what colour it was supposed to be. Look, apparently that colour is called school, which is an odd name for it, I think, but there you go. I got some of that from Paragon Paint, so we can bring it back to its former glory. So there's the screw. Just give you a quick view of it. So this is the plain portion I've been banging on about. There's the spline that the skew gear or helical gear goes onto, and the thread that the Simmons nut was on, and the washer. So yeah, there you go. It doesn't look too bad actually. Well, I've been staring at it for weeks and months, and it looks fine to me. Can't see anything too untoward. Obviously we'll give it a clean up and a proper look over. Good dose of the Mark 1 eyeball. Yep, so that's that out. So I'll try and have a look up inside the pocket here where the thrust bearing was resting and see if I can see any bushes. I can't actually feel anything. I think that was just, I thought I could feel something, but it's actually just the washer sitting on the top there that I couldn't get off. So I think that was just journaled in a plain cast iron bore. Anyway, I'll show you that in a minute. So you'll remember this modern classic from the other day. I just want to talk about one or two misgivings that I might have, that I do have, and that some people might possibly have about this. Lifting on the cast iron, obviously I'm across the ways here, but they're well protected. The way that's in there and the way this is going to lift, this is going to be in tension, and it's going to be trying to open these out. Now, I've spoken about how grey cast iron likes to break out, and in swing out sister fashion. But the thing is, this is about 1 3/4 inches thick. It's about 40 millimeters. So I think for the job it has to do here, it's going to be fine. We're not going to have any issues with it. Obviously, once I've got the knee off, I want to get it down as quickly as possible. And that was one reason, well, not the primary reason for removing the lead screw now, but it means that I can get this straight out. I didn't want to damage the lead screw, and I didn't want to damage anything else. I want this to be in use basically for as short a time as is physically possible. So I'll get you on the tripod now, and we'll get these 5/16 UNC bolts out of the clamping strips, and we'll get this off. So again, I've used a pipe cleaner to get any congealed dirt or swarf or any of the detritus out of the sockets of these cap head screws. And you'll recall from earlier that I did take out the lubrication fittings, and I've sent up these. Probably not necessary really, but it's just an extra bit of insurance, because to make sure these go on the right way when they go back on, which You can't really get it wrong because of the position of the locking bolt, but it's just a, you know, as I say, belt and braces basically. So I'll crack on. Now, the great thing about what I've done, taking that lead screw out now, is it's protected the lead screw, but it's also meant that I can just take this straight out, and I've got a little bit of just the merest smidgen of tension on the crane at the moment, because I don't want too much tension on that. As I say, the way that's rigged, it's unlikely that it's going to break out, but you just never know. I don't want to take any chances with it, because if this gets damaged then it's all over. But it does have to come off, and I cannot see any other way of rigging it up other than that. These are remarkably not tight, which kind of gives me pause. I'm just wondering if, I'm actually interested to find out what type of arrangement there is in here for setting the gap, for setting the clearance, or for setting the actual the running clearance for the ways. Oh, it's coming off. So we're about to find out anyway. I'm sure it will be underwhelming, but we'll find out anyway. Here we go, this is the last one coming out now, so hopefully this should now come off. Yeah, and it is doing, there we go. So there are absolutely no shims or anything else in that keeper plate, or strip as the manual calls it, rather unceremoniously. So it's clearly just machined to the right size, and then the tension of the bolts is what sets the running clearance. So we shall put that there. Here's the locking bolt. Right, now that's not going to come out easily, is it? Right, what am I going to do about you? Because you're not going to come off. That's interesting. Right. I shall bring you back when I have decided what to do about that. So this is what the locking pins look like. Basically, it's just a threaded bolt, or a threaded pin rather, with a slot in it that just pulls in on the back of the ways. And this is a bush here, which top hat bush, which just journals that in the casting. So when I pull this forwards with the crane, obviously these are gonna it's gonna slide off the pin here, and that'll probably drop down, but it's of no great consequence. So we'll get ready to start moving everything now, because the other side's free now. Okay, you join me as we're ready to go for a removal. I know I said I didn't really want to lift this up anymore, but I've had to do so because you can just see here there's a stub for the coolant supply from the pump that's in the weldment, in the base weldment, and that was going to foul on the side of the knee casting, so I've just had to lift it up to clear that. So I'll try and keep you in a position where you can see what's going on. I'm going to try and slide the crane out now, so I'm just going to have to move you slightly so I can get the crane out, and then as things progress I'll keep you on the move so you can see what's going on. Right, so you should have, yeah, you've got a pretty decent view, so here we go. Right, I'm moving it! There's only two people, I suspect, watching this, potentially watching this, who got that joke. Right, that's one of the locks has come out there, so here's the second one that's the second one free now. We'll take that bush out. Stop that bashing against the ways. Take the other bush out as well on the other side. No, it doesn't want to come out, so we'll leave it for now. Right, let's get this away from those ways before it starts banging into them. Not that it's going to, but right, come on you. Right. The knee is off. I repeat, the knee is off. And it is horrible in there. Right, I want to get this down as soon as I possibly can. So I couldn't get my piece of 15mm marine ply, so I'll get something else to lower this down onto for the time being. Just going to move the tripod and clatter into everything so you can actually see what's going on. Not the best lighting there, is it? But right, we'll get this down. So I'll get this down now. And here's one Harrison mill minus one knee. So there's the vertical ways, and there's where it came from. So this is what the lock-in pins look like. You can see, as I said, just basically it's a relieved pin with a thread on the end of it. The other one's there, so they dropped out nicely and didn't do any damage or anything like that. And here is the knee. So what I've done is I've lowered it onto some suitable blocks of wood, and it's in a stable position now. I'm going to keep it on the crane for the time being because I will need to move it again to work somewhere more suitable to work on it. But we can leave it in the position it's in for the time being. It's not going to move because the crane's still got a little bit of the weight, and it's well down on those blocks of wood and that piece of ply. So I'm going to take you in now and show you inside there once I get a suitable light, so I'll bring you back there. So there you go, that's me lying down on my workshop floor, the things we do for art. So you can see there, this is where the lead screw was journaled, and it is, as I suspected, there's no bushes in there. It is just a plain cast iron bearing that the plain portion of the lead screw was running in. And you can see here the nut on the back of the shaft for the input, and you can just about make out the helical gear. It's all covered in grease and swarf and goodness knows what else. So the next job will be to get that cast iron sleeve out that has the bushes in it for the journals for the steel shaft that's got the helical pinion on it. So that'll be the next thing to do. It's going to be a lot easier to work on now it's off the machine. I'm really glad I've taken it off because I don't foresee any massive issues in getting these V-ways set back up again. I think it was just the tension of the bolts on the keeper plates that was actually setting that up. So it shouldn't be too bad to get it done. Might be a bit fiddly, but I mean these don't look in too bad condition. Obviously they're absolutely clarted in grease, as everything else is. But you know, there doesn't appear to be any damage or dents or nicks or anything like that. Nothing major anyway. So with that, I'll bring you back when we're in a position to start stripping this out, and what a clean-up job that's going to be. It is absolutely manky in there. Oh well, such is life. So there you are, one Harrison mill knee casting. Well, that's me now sat next to a kneeless milling machine. So it's getting smaller and smaller and lighter as I take more bits off it. But as the old saying goes, how do you eat an elephant? One bite at a time. So that's what we're going to be doing with this machine, just taking it one step at a time. Now I did say that I was going to show you the threads in the lead nut. I'm going to leave that until next time. The tentative conclusions that I've come to at the end of this phase of the dismantling is that the lead nut is going to need to be replaced. The threads in it are worn to the extent that I think they're not going to be usable. So it looks like I'm going to have to make a new lead nut. The lead screw itself I think is in decent condition. We'll do some measurements on it in the next episode, and we'll find out what like that is. It, as far as I can tell from the sort of the rudimentary measurements I've taken so far, it's a 1 inch by 5 TPI Acme. So that's the thread I'm going to have to generate in the new lead nut. So I need to get myself a nice piece of phosphor bronze for that as well. So that'll be for next time. So I hope you'll join me then. I think in the next video we'll probably be continuing on with the tool manufacture for removing these bearing locating bushes, and as I said, we'll do some measurements on the lead screw, and I'll show you the lead nut threads. If you're watching this video and you're not subscribed to my channel, please consider doing so. It can only help me to further the channel and to move things forward. And if you are subscribed, and then I would say to you, thank you very much for doing that, and I hope you've enjoyed the video. So we'll see you next time.